Hi there, here's our first example of section G3. For what value of y must PQRS be a parallelogram? So what we're given here are measures of the sides. And so one of the things that we have to remember is in a parallelogram, we know that the opposite sides are congruent. So we could set the opposite sides congruent to each other. So the top would be congruent to the bottom. So we could say 3x minus 5 would have to equal 2x plus 1. And we could solve that for x. So let's do that. Let's subtract 2x from both sides. And then let's add 5 to both sides. So x would have to be 6. But the question says, what's the value of y? So the other side, it says y would have to equal x plus 2. Well, that's why I needed to do this in order to answer that question, because I needed to know what x was. X is 6. That's going to go there. So y is 6 plus 2. So y would have to be 8. And we could even go a step farther and say, well, what are the measures of the sides? Well, this one would be 8. And this one would be 2 times 6 plus 1. That would be 13 if we wanted to know the actual lengths. But since we only needed to know what y was, we could stop at that answer. The last thing here is, can we prove that these are parallelograms? So do these follow any of the properties that would prove that the quadrilateral is a parallelogram? So if we take a look at the first one, I see that the opposite side, AB and DC, is congruent. But that's not enough. I would need to know that AD is also congruent to BC. Okay? So I can't use that particular property. I also see that A and D are supplementary. They add up to 180. But that's not enough by itself, because I'd have to show that either B is 130 or C is 50, one of the two, in order to prove it with that. However, there is one property, and if I grab the notes, the very last property from these notes said if you can prove one pair of opposite sides is congruent and parallel, then you have a parallelogram. And I think we can use that one, because if you look, because this is, this set of opposite sides is definitely congruent. So AB is definitely congruent to DC. But are they parallel? And I think we can also say that they are parallel to DC. And why is that? Because these are two lines cut via transversal. And those are same side interior angles. And because same side interior angles are supplementary, that proves that these two lines are parallel. So we can also say that that's parallel. So since we have both of these properties, we can say, yes, this is definitely a parallelogram. Our last example here is, can we show that these are parallel? And the answer here is no, we can't do this, because remember, in a parallelogram, the opposite sides are congruent, and these opposite sides are definitely not congruent. Not congruent opposite sides. So we don't have enough information here. We do have enough information to show that they're not parallel. It's not a parallelogram. And there's our examples here for section G3.